Namaste to all. Welcome to Disha online classes. In previous videos we discussed angle, the definition of an angle, and units to measure an angle, that is revolution. There are three units: revolution, degree, radian. Okay, and also we discussed problems based on these revolution, degree and radian and arc length also. Okay, yes. So from today's class, let us discuss with the trigonometric functions. In your SSLG, you studied trigonometric ratios. You are generalizing the ratios to the functions. You will come to know what exactly the meaning of function. It's very important. Mathematics, the word function is very, very important. You will come to know what exactly the definition of a function. Okay. And basically, there are 6 trigonometric functions are there. Okay, that is sin theta, cos theta, tan theta, secant theta, and cosecant theta, and cot theta. Is it right? Sine function, cosine function, tangent function, cotangent function, secant function, and cosecant function. Okay, these are all 6 trigonometric functions. See, how to define those 6 trigonometric functions? Okay, we will see by using right-angled triangle. Okay, suppose here triangle ABC. This is the triangle ABC, and here the triangle is a right-angled triangle. Suppose this is the theta. Okay, yes. So how to define all those 6 trigonometric functions by using this triangle ABC, right-angled triangle ABC means, we'll see. First one, that is sin theta. Okay, sin theta or sin function. Okay, so how to define sin function? So here sin theta, angle is here, theta is there. So sin theta is equals to opposite divided by hypotenuse. So here AB is the opposite. Here AB is opposite side, and this is the hypotenuse. And here BC is adjacent or base. Okay, yes. So sin theta is the ratio in a triangle, right angle triangle. It is the ratio of opposite to the hypotenuse. So sin theta is equals to opposite divided by hypotenuse. Okay, yes. So sin theta, how to define function? It is the ratio of opposite to the hypotenuse. So then next, second one, cos theta or cosine function. So here angle is theta, so cos theta is equals to, it is the ratio of adjacent to the hypotenuse, adjacent or base, adjacent to the hypotenuse. These are all very important definition. And third one is tan function or tangent function. So how to define this tangent function means tan theta, which is equals to, so it is the ratio of opposite to the adjacent. So here opposite is AB, adjacent is BC. Opposite to the adjacent. Okay. And next, fourth one, secant theta. So how to wait? We'll write it. Instead of secant theta, I will define fourth one, that is cosec theta or cosecant theta, cosecant function. So cosecant function, we will write cosec theta. The angle is theta is there. So cosecant function or cosec theta is equals to, it is the ratio of hypotenuse to the adjacent. It is the ratio of hypotenuse to the adjacent. And fifth one, that is secant function. So secant theta is equals to, it is the hypotenuse to the adjacent. So it is the ratio of hypotenuse to the adjacent. Sorry, hypotenuse to the wait a minute. Here hypotenuse to the opposite. Which one? Cosec theta. Hypotenuse to the opposite. This is hypotenuse to the adjacent. Right. Last sixth one is, that is cotangent function or cot theta. Cotangent function or cot theta, which is equals to, it is the ratio of adjacent to the opposite. It is the ratio of adjacent to the opposite. So this is the adjacent to the opposite. So these are all the definitions of a sixth trigonometric function. How will define? By using sides of a right angled triangle, we will define all these six trigonometric functions. First one is sine function, cosine function, tangent function, cosecant function, secant function, and cotangent function. Okay, yes. From these definitions, we will come to one conclusion, or we will give a relation between these six trigonometric functions. Okay, relation between these six trigonometric functions. See, here sine theta, sine function, it is ratio of opposite to the hypotenuse. Okay, and here cosecant theta is there. So it is the ratio of hypotenuse to the opposite. Hypotenuse to the opposite. That means sine theta opposite divided by hypotenuse, cosecant theta hypotenuse divided by opposite. That means cosecant theta is the reciprocal of sine theta. Na? Cosecant theta is reciprocal of sine theta. We can write this hypotenuse by opposite as 1 divided by opposite divided by hypotenuse, same as sine theta. Is it right? So sine theta. So here I will give relations. Okay. First one is sine theta, which is equals to 1 divided by cosecant theta. Okay. Cosecant theta is the reciprocal of sine theta. Similarly, sine theta is a reciprocal of cosecant theta. We can write cosecant theta is equals to 1 by sine theta also. Both are same. So sine theta is equals to 1 by cosecant theta, or cosecant theta is equals to 1 by sine theta. See, cross multiply these two. Just sine theta into cosecant theta is equals to, which implies sine theta into cosecant theta is equals to 1. Sine theta into cosecant theta is equals to 1. That means product of sine function and cosecant function is 1. So then next one is cos theta. It is the ratio of adjacent to the hypotenuse. See, secant theta is here, hypotenuse to the adjacent. So observe these two. So here secant theta is the reciprocal of cos theta. So similarly, cos theta is also reciprocal of secant function. So here also, so cos theta is equals to 1 divided by secant theta. So then cos theta into secant theta is equals to 1. And the third one is tan theta opposite to the adjacent. Here cot function cot theta is adjacent to the opposite. So again tan theta is the reciprocal of cot theta. So cot function is reciprocal of tangent function. So therefore tan theta, which is equals to 1 divided by cot theta. So then tan theta into cot theta is equals to 1. Tan theta into cot theta is equals to 1. Okay, these are all by the definitions, results by the definition. Okay, then next again two more relations are there. See, sin theta, just divide this sin theta and cos theta. Okay, so sin theta divided by cos theta is equals to, see, sin theta divided by cos theta is nothing but it is the ratio of this sides. Okay, that means opposite by hypotenuse whole divided by adjacent by hypotenuse. So hypotenuse cancelled, then opposite by adjacent. So opposite by adjacent is tan theta. So then tan theta can be written as, it is the ratio of sin theta to the cos theta. So tan function is equals to, fourth one, tan theta, which is the ratio of sin theta to the cos theta. Okay, and we know tan theta is reciprocal of cot theta. So cot theta can be written as, so just take reciprocal. So that is cos theta divided by sin theta. Okay, so cot theta is equals to cos theta divided by sin theta, because cot function is, it is the reciprocal of a tan function. So that cot theta is cos theta divided by sin theta. Okay, so this is all by the definitions of a trigonometric functions. These identities, relations are very important. Okay, yes. Then next is, we will move to the standard angles. That means there are some already defined angles are there. That means calculated values for different angles. So those angles are some standard angle. We will see. Okay. For those angles, these trigonometric functions values are, what are those values? We will see. Right. Just give a table. So here angles in a degree. Okay, or you can take in a radian also, no problem. You know already how to convert a degree to radian and radian to degree. Okay, yes. So here 0. Next is 0 degree, pi by 6. So pi by 6 is 30 degree. Okay, pi by 6 is 30 degree. Pi by 4, 45 degree. Pi by 4 is 45 degree. Next, pi by 3, 60 degree. Pi by 2, 90 degree. Next, pi is 180 degree. 3 pi by 2, 270 degree. 2 pi is 360 degree. Okay, you should know in that means radian to degree, degree to radian. Okay, yes. So here I will take functions, trigonometric functions. See, this is sine function, cos function, and tan function. I will define only these three, because you know, if you know the sine function, then definitely it is sine is the reciprocal of cosec, reciprocal of cosec theta. Okay, and cos theta is reciprocal of secant theta. Next, tan theta reciprocal of cot theta. Okay, yes. Sine 0, sine 0 value is 0. You already studied in SSLC. Okay, sine 0, 0. Next, sine 30 degree, 1 by 2. Next, sine 45 degree, 1 divided by root 2. Sine 60 degree, root 3 divided by 2. Sine 90 degree is 1. Next, sine 180, 0 sin 3 pi by 2, that is sin 270 degrees minus 1 and sin 360 degrees 0. Here cos function, so cos 0 1, just rewrite these values from 90 degree to 0, reverse. So cos 0 is 1, cos 30 degrees root 3 by 2, next cos 45 degree 1 by root 2, cos 60 degree 1 by 2, cos 90 degrees 0. Next cos 180 degree minus 1, cos 270 degree 0, cos 360 degree 1. And next tan function, tan function is a ratio of sin theta to the cos theta. Just divide these values. 0 divided by 1 is 0. 0 divided by anything always 0, provided denominator must be not equals to 0. Next 1 by 2 divided by root 3 by 2, so 1 by root 3. So tan 30 degrees 1 by root 3. Next tan 45 degree, so take this ratio 1. Next tan 60 degree, root 2 cancelled, root 3. Next tan 90 degree, so 1 divided by 0, infinity or not defined. Okay. Next tan 180, so 0 divided by minus 1 is 0. Next tan 270 degrees minus 1 by 0 is not defined, that is infinity. And tan 360 degree 0 by 1 is 0. Okay, these are all the basic standard angles you should know. This is basic. You should have these values in your mind. Okay, yes. So then how to define, you know already, cosecant function. So cosecant function is reciprocal of sine. Sine function is reciprocal of cosecant. If you know sine 0, then definitely just take reciprocal of this sine 0. You will get cosec 0. So then cosec 0 is 1 by 0, infinity. Is it right? Next, cosec 30 degree, 2 by 1 is 2. Cosec 45 degree, root 2. Cosec 60 degree, 2 by root 3. Next, cosec 90 degree is 1. And take this reciprocal. Okay. Similarly, secant function and here cot function. Okay. That means you should know these basic values. These are very important. Okay. Yes. Then next is, we'll move to the trigonometric identities. These are very, very important. Trigonometric identities. We'll see what are those trigonometric identities. Okay. Yes. So there are three important trigonometric identities are there. So first one is trigonometric identities. Okay. So first one is sin square theta plus cos square theta is equals to 1. So second one is 1 plus tan square theta is equals to secant square theta, and third one is 1 plus cot square theta is equals to cosecant square theta. So first identity, that is sin square theta plus cos square theta is equals to 1. We'll prove first one. Okay, that is sin square theta plus cos square theta is equal to 1. How means? Okay, first I will consider a unit circle. Unit circle, you know, unit circle is nothing but a circle whose radius is 1 unit. Okay, a unit circle whose center is at the origin of the coordinate system. Suppose this is the y-axis and this is the x-axis. Okay, this is the origin of this coordinate system. That means point of intersection of x-axis and y-axis. So suppose this is the unit circle. Unit circle means radius is 1 unit. Here to here distance is 1 unit. Okay, yes, or year to year distance is 1 unit. Let P be any point, P be any point on the unit circle whose coordinate is a comma b, whose coordinate is a comma b. See, in coordinate system, suppose here a point P, x comma y is there. So what exactly this x and this y? Okay, this is the x is nothing but x coordinate, first one. This is y coordinate. What actually x coordinate tells? X coordinate tells us it is the distance of a point from the y axis. Year to year distance is x. Here y coordinate says that it is the distance of a point from the x axis. So x axis to the point distance is y. So similarly, here a comma b is there. Here a is x coordinate, b is y coordinate. So here what exactly this a means? It is the distance of a point P from the y axis. So year to year distance is a. Then next, b is the distance of a point from the x axis. Okay. So year to year distance is b. Then next, I will this is the point A, B, C, and D. Okay, yes. I will join. That means A, O. This is the origin O, A, O, P. I will join O, P. Okay, I will join O, P. Now see, observe here. This length is there, na? AP. AP is suppose this is the arc is nothing but portion of a curve. So suppose AP length is x units. Okay, x units. Then angle subtended by this AP arc at the center of this unit circle is x radian. Okay, so then I will define sine function and cosine function in this triangle. Here P, O, this is the point. I will take this as the Q. Okay, this. See, observe here. Year to year distance is A. So this line is parallel to this line. If two lines are parallel, that means their distance is also same. So year to year distance is A. So O to Q distance is also A. Next, Q to P distance is B. Okay, yes. So now from the triangle, here triangle is O P Q or P O Q. From the triangle P O Q, I will define a sine function. Sine function. So sine x is equals to. So sine function definition, opposite divided by hypotenuse. So here opposite is B is there. Sine function opposite is B. Hypotenuse is this one. Okay. So B divided by S. See, observe here. Hypotenuse is here. It is the radius of the circle. Is it clear? See here, OP is a radius of this circle. Here circle is unit circle. Therefore radius is 1. So if radius is 1 unit, then length here OP is 1. Okay. So sine function, sine x is equals to, can take here PQ divided by OP. PQ length is B is there, OP is radius, so that is 1 unit. So sine x is equals to B, or B is equals to sine x. Okay. So sine x is equals to. Then next, I will define again cos function. So cos x is equals to. So cos function, it is the ratio of adjacent to the hypotenuse. So adjacent is here OA. OQ. OQ divided by OP. So OQ length is A is there. OP is radius, so 1 unit. So A is equals to cos x, or cos x is equals to. Okay. So in a unit circle, P be any point whose coordinate is A comma B. So then here A is equals to cos x and B is equals to sin x. So then shall I write here, that is A comma B is there in place of A cos x sin x. So coordinates of any point P, I will take here also, this is the point P or here point P, arbitrary point. This coordinate is cos x comma sin x. Any point on a unit circle whose coordinates of a point is cos x comma sin x. Then next, now triangle OQP or POQ, triangle POQ is a right angle triangle. Is it right? See, PQO, your angle is 90 degrees. So from this right angle triangle we will use Pythagoras theorem. Okay, so according to Pythagoras theorem, shall I write PQ square plus PQ square plus QO square which is equals to OP square. So here PQ square, PQ length is B, so that is B square. Next QO square is A square is equals to OP is radius, so radius of unit circle is 1 square is 1. Then B is here, sine function, no? So B is equal to sine, so then B square is sine square x plus A square is cos square x is equals to, so sine square x plus cos square x is equal to 1. Okay, we proved sine square x. See here, I took here angle is x radian, so that here sine square x plus cos square x is equal to 1. Suppose here angle is theta, then sine square theta plus cos square theta is equal to 1. Just this is theta is angle, here also x is an angle. Okay, we proved this sine square theta plus cos square theta is equal to 1 by using unit circle. Okay, considering a unit circle whose center is at the origin of the coordinate system. Similarly, we can prove the two also. Okay, yes. See, these three identities are important. Okay, sine square theta plus cos square theta is equal to 1. Again, just I will rewrite the identity sine square theta plus cos square theta 1. How means, see, I will keep the sine square theta as it is. I will take this cos square to the that side, so that is 1 minus cos square theta. That means sine square theta is equal to 1 minus cos square theta. Then sine theta is equals to, so that means square, taking square root on both sides. So then sine theta is equals to under root of 1 minus cos square theta. Okay, sine theta is equals to under root of 1 minus cos square theta. Similarly, cos square theta is equals to 1 minus, keep this cos square theta as it is, take sine square theta to that side, so 1 minus sine square theta. So similarly, then cos theta is equals to under root of 1 minus sine square theta. So these are the important relations. So sin theta is equal to under root of 1 minus cos square theta. Cos theta is equals to under root of 1 minus sin square theta. Okay, you should know these identities. Conversion also. Okay, right. Then next, second one, that is 1 plus tan square theta is there. 1 plus tan square theta is equals to secant square theta. You should know the relation, please note down. 1 plus tan square theta is equals to secant square theta. So keep this 1 here as it is. So take this tan square theta to that side, then secant square theta minus tan square theta is equals to 1. Is it clear? So secant square theta minus tan square theta is equal to 1. Next, 1 is equals to, how to write this secant square theta minus tan square theta? This is one identity, please. How to write this secant square theta minus tan square theta? By using a square minus b square formula. So how to write? So suppose this is a square minus b square. A square minus b square is equal to a plus b into a minus b. But here a is secant theta, b is tan theta. So that secant theta plus tan theta into secant theta minus tan theta. Okay. The next step is I will take this secant theta minus tan theta to this side. So what will happen? So here already 1 is there. 1 divided by secant theta minus tan theta is equals to secant theta plus tan. Very important, this one. That is 1 divided by secant theta minus tan theta is equals to secant theta plus tan theta. Okay, na? So 1 plus tan square theta is equals to secant square theta. Then secant square theta minus tan square theta is equal to 1. So 1 is equal to, this is a square minus b square. So a plus b into a minus b. So then I will take this secant theta minus tan theta to that side. So then 1 divided by secant theta minus tan theta is equals to secant theta plus tan theta. Or secant theta minus tan theta is equal to 1 divided by secant theta plus tan theta. Okay. So this conversion, writing the identity in different form is also very important. Or secant square theta, take this one to this side. So secant square theta minus 1 is equal to tan square theta. Secant square theta minus 1 is equals to tan square theta. This is also important. Okay. That means take this plus 1 to this side, then minus. So secant square theta minus 1 is equal to tan square theta. Then or secant tan theta is equal to under root of secant square theta minus 1. Very important. Or secant theta equal to under root of 1 plus tan square theta. So conversion is very important, please. Okay. Yes. Then next, third identity is, that is 1 plus cot square theta. 1 plus cot square theta equal to cosec square theta. So again, how to write this one? See directly. So taking this plus cot square to theta to this side. So then cosec square theta minus cot square theta is equal to 1. Similarly, like this. And then next is 1 divided by cosec theta minus cot theta is equals to cosec theta plus cot theta. Same procedure what we followed here, that is a square minus b square, then you will get this important relation. And then next is cot square theta is equals to, keep this cot square theta as it is, take this plus 1 to this side, then cot square theta is equals to cosec square theta minus 1, or cot theta is equals to square root of cosec square theta minus 1. Next, or cosec theta is equal to square root of 1 plus cot square theta. Cosec theta is equals to square root of 1 plus cot square theta. Identities are important, please. Okay, so these formulas will help in solving the problems. Okay, so that first you need to understand what exactly this one. First, just remember this one, and from this one only we derived all these results. Okay, yes. Then next, identities are over. Okay. Then next is sines of a trigonometric function. Sines of a trigonometric functions means there are 4 quadrants are there. Is it right? We will see one by one. Trigonometry. This is very important and like in your physics, chemistry, and so on. In physics, like electron, protons are basic fundamental units. Likewise, this trigonometry. Next, science of trigonometric functions. Science of trigonometric functions in different quadrant. In different quadrant. Okay, there are 4 quadrants are there. Okay. This is first quadrant, second quadrant, third, and this is fourth quadrant. Okay. Circle. So what are the signs of trigonometry functions in different quadrant? So what is the sign of sine function in first quadrant, second quadrant, third quadrant, and fourth quadrant? You see, okay. Generally, all trigonometric functions are positive in first quadrant. This is first quadrant. All trigonometric functions are positive. All trigonometric functions are positive in first quadrant. Next, in second quadrant, only sine and its reciprocal. That means sine function and cosine function. Just I will write yes. Here all trigonometric functions are positive. Here sine function and its reciprocal is positive. In third quadrant, tangent function and its reciprocal is cotangent. That means tan function and cot functions are positive in third quadrant, and in fourth quadrant only cos function and its reciprocal, that is secant function. Okay. In first quadrant, all trigonometric functions are positive. In second quadrant, sine function and its reciprocal, that is cosec function, positive. In third quadrant, tan function and cotangent function, positive. In fourth quadrant, cos function and secant theta, secant function are positive. That means, in generally to remember, A is nothing but all. S is student. T means tea. C means coffee. All students take a coffee. Okay. A is all student take a coffee. Just to remember, that's it. The thing is that. Okay, na? A, S, T, C. In first quadrant, all trigonometric functions are positive. In second quadrant, only sine and its reciprocal cosec theta function positive. In third quadrant, tan function and cot function are positive. In fourth quadrant, cos function and secant theta are function. That means in second quadrant, other than sine and cosec, all other 4 are there, na? Cos theta, secant theta, tan theta and cot theta are negative. Okay. Suppose this is the 0 degree, this is 90 degree, that is pi by 2. Next, this is 180 degree, that is pi. This is 3 pi by 2, 270 degree, and this is again 360 degree, that is 2 pi, 2 by 80. Okay, so that means 0 to 90 degree all are positive, that is in first quadrant. 90 degree to 180 degree, second quadrant, sine and cosec are positive, remaining are negative. Next, in third quadrant, that is 180 degree to 270 degree, that is pi to 3 pi by 2, only tan function and cot functions are positive. And in fourth quadrant, only cos theta and secant theta are positive, remaining angles are negative. Okay, so this is all about the signs of a different trigonometric functions in different quadrants. Different quadrants. There are 4 quadrants: first quadrant, second quadrant, third and fourth quadrant. Okay, and in the next class we will discuss the graphs of these trigonometric functions. Graphs, very important. Based on graph only, we can say many properties or nature of the function. Okay, in the next class we will discuss the graphs of a function and the domain, range and वगैरह. Okay, yes, thank you all. Namaste.